This UCSD TV program is a presentation of University of California Television for educational and non-commercial use only.
Compared to our nearest ape relations, humans are particularly other-regarding, not necessarily uniquely eager to share, but extremely eager to share and to cooperate, even with non-kin. Spontaneous helping and voluntary gift-giving are documented for every human society ever studied. Even quite young children will pick out something that they have reason to think someone else will particularly enjoy and spontaneously offer it. Nevertheless, as Christophe just explained, there are conditions, and it may depend on which computer you use, but there are conditions when chimpanzees as well do help one another. For example, common chimpanzees sharing some meat, or a bonobo female allowing some other infant to remove some food from her mouth. But these tend to be preceded by begging, and often more nearly illustrate scrounging than the spontaneous and considered gift-giving that we see in humans. When combined with intention reading, which is not unique to humans, but very well elaborated in humans, these other regarding impulses equip humans to coordinate with others to achieve common goals, as in the case of these Kayapo tribesmen, and they've waded into the water and they're beating this timbo plant with sticks, nothing here beyond Stone Age technology. They're releasing a toxin into the water so that women and children can come around with baskets in the shallow water and gather up the stunned fish. A tremendously valuable protein resource not available to other apes. So why haven't other apes gone this route? In one of the more ambitious efforts to try to understand exactly where the differences lie, Mike Tomasello's team at Leipzig have designed a special battery of socio-cognitive tests, and they've compared 105 human children, 2.5 years old, 106 chimpanzees, 32 orangutans, and just in light of what Christophe just said, I actually agree with his criticisms, but I cite these studies because they're the best we have. They are captive animals, yes indeed. What they found was that in the realm of spatial cognition, remarkably similar capacities, quantities, assessing many versus few, very similar causality. What happens when I push this with a stick? It falls over. Very similar. Where these creatures differed was in terms of social learning, watching a demonstrator solve a problem and then doing it the same way, communication, reading where I'm pointing, and what psychologists call theory of mind, attributing a mental state to others. Now look, it's not that chimpanzees and orangutans don't have these capacities, indeed they exhibit them, it's that humans are better at them. Okay, why? Well, I used to think, oh sure, I know. It's because we've got these brains 3 times bigger than a chimpanzee's or an Australopithecine, brains capable of symbolic thought and language. And then, you know, I started to learn a little bit more about it, read people like Peter Hobson convincing me, whoa, before language there had to have been something else, something that propelled us into language, something that could evolve in tiny steps, that could make one person want to join up their mind with someone else. There had to be these emotional links first. I also assume, we have these special capacities. Andy Meltzoff showed us that right from birth, little babies can imitate someone else's facial expressions, this empathy and imitation going on. Oh, sure, that's the answer. We're wired differently. And of course, now we know that, other chimps as well, right from birth. The wiring is there. Something else is going on. And one of the differences seems to be that little humans get more and more interested in this stuff as time goes by, so that by 9 months, for example, a baby will hold something out, an object, and want to know what someone else is thinking about this object. And little chimpanzees don't do this. Well, previous efforts, in fact, you've heard some today, to explain our peculiarly pro-social capacities in humans have focused on selection pressures on males to cooperate in hunting or intergroup conflict and so forth. Yet think about it. The differences are found in both sexes and emerged very early in development. And this is one reason my attention has been drawn to the very different rearing environments of humans and other apes. In all apes, mothers are very possessive of new babies, in all the non-human apes, and they are their sole source of nutrition, warmth, locomotion, security. This mother chimpanzee is not going to let that baby out of her touch for one moment, day or night, for the first 6 months of life. Thereafter, she's going to go on nursing for up to 5 years. By contrast, women in foraging societies, wherever they have been studied, exhibit a remarkable maternal tolerance just postpartum to other people handling their babies. San and Hadza babies, for example, are going to be held by allo mothers 25 to 30% of the time, right from birth onward. This baby has just been handed over to his grandmother, and she's massaging the scalp. This FA infant in Central Africa is going to spend 60% of daytime being held by allo mothers, which is not to say mothers aren't important. Babies spend the night with their mothers. They're centrally important, the main attachment figure. The point is, unlike other great apes, we are sharing infants with others. Who are these group members other than the mother, the allo mothers helping to care for babies? Well, they're mostly relatives, fathers, brothers, cousins, the male allo mothers. The female allo mothers are mostly sisters, aunts, and grandmothers. Why do we need all this help? Well, other apes, once weaned, provision themselves. But human children are going to remain dependent on nutritional subsidies from others for years. If you think it's unusual that your 20-year-old is still at home, it's not. It takes 10 to 13 million calories beyond what a child provides himself to rear a human from birth to age 18, far more than a foraging mom could provide herself. And there's going to be a new baby before the older children are mature because interbirth intervals in hunter-gatherers tend to be shorter than in other apes. Well, how was this possible? It used to be assumed that, oh, sure, it's Father the hunter. He provisioned his mate, her offspring, in line with a sex contract, guaranteeing him certainty of paternity. This is why humans became bipedal, so he could bring the meat back. Well, the problem is work by James O'Connell, Kristen Hawkes, Kaplan Hill, others. The rates of success among hunters with Pleistocene tools at their disposal would be too variable to provide for children who have to eat several times a day. As you heard earlier today, maybe 5 hunters, more than one for sure, and they need to share. And as Chris Baum pointed out, that sharing can often be pressure from below. Don't be stingy or you'll be ostracized. As hominins included more meat in their diet, it would require multiple hunters, and who would pool and redistribute it, but you also need women gathering plant foods that's more reliably provided. So you need this division of labor coming back to a central camp. Well, in line with what people like Kristen Hawkes have been arguing for some time. About 60% of the calories in, whether you're looking at San, Bushman, or at Hadza, are due to plant foods brought in by women, and about 40% from meat and honey from men. And whereas mothers with new babies are actually bringing in less food, much more than they're consuming is being brought in by these post-reproductive women. Hawkes has called them the hardworking Hadza grandmothers, but in fact, they don't necessarily have to be grandmothers. This is a great aunt pulling aside an enormous boulder to get at the tubers underneath. These post-reproductive allo mothers are bringing in up to 3,500 calories a day. Okay, so in order for this kind of system to work, and it's what sociobiologists have called cooperative breeding, that is any species where alloparents, group members other than parents in addition to parents, help to both care for and provision young. In order for this to work, you have to have quite flexible residence patterns. And you have to have people being able to move between groups, gravitating away from adversity towards opportunity, where opportunities are not just access to food and water, but access to kin who will help you, even non-kin who might help you. There's a lot of what Randy would call social selection going on in residence choices. You can have a grandmother moving to another group to live near the daughter who needs her most because she's got a stepfather instead of a father in residence. A typical hunter-gatherer pattern is for a young man to come live with his wife for a time, hunting on her family's behalf before children are born, so that she's got kin there when her first offspring arrives. A very vulnerable time across all primates. First births, vulnerable for the mother, especially vulnerable for the infants. So a lot of alloparental assistance going on. Well, some of you may still be wondering, why would anyone help? And I think that we've already heard today about Hamilton's rule, and I agree completely with Christoph's point. It's not just about kin selection. It's why I prefer calling it Hamilton's rule, but there are these other factors involved, so that, for example, if a male is very well fed, the cost of helping somebody else is low. If he might be the father, doesn't know for sure he is, he's still going to stuff food in the mouths of these little chicks. But what's interesting is that if over time it's been advantageous to help someone else's young, the threshold for responding to cues like a gaping mouth goes down, so that you can have mistakes like this cardinal stuffing food into the mouth of a gaping goldfish. And it turns out that in highly social species with particularly helpless young, other group members are especially susceptible to enticing cues from baby. This is my neighbor's Jack Russell Terrier, who chased away a very surprised mother cat, began to spontaneously lactate, adopted her kittens, and reared them. This happens in non-human primates as well. This is a Cebus monkey who adopted and nursed a baby marmoset that she found abandoned in the woods. These misdirected parental care examples happen. Well, our species, humans, is wide open to babies as sensory traps. And this is well known to Madison Avenue, well known to filmmakers. Some of you may have seen the recent blockbuster film, Babies. Look at the film, but then turn around and look at the audience. They're all just agog. No wonder. We know that the orbitofrontal cortex and the regions of the brain that are set up for rewarding us when we see something we like light up when people look at babies, and it is true for both parents and non-parents, for males as well as females. So even though in other apes, infants are cared for exclusively by mothers, across the animal kingdom, cooperative breeding has evolved many times. We don't need to talk about how special humans are to explain it. It's found among social insects, 9% of 10,000 species of birds, maybe 3% of 5,400 species of mammals. It's especially likely to evolve in the social carnivores and in non-human primates, and human ones too, I'm about to argue. Allomaternal care of infants is found in over half of all the 300 to 400 species of primates that are out there. Shared care and at least minimal provisioning is found in perhaps a quarter of these species. However, only in humans and in the subfamily Callitrichidae, that's marmosets and tamarins, do you have full-fledged cooperative breeding. That is alloparental care plus extensive alloparental provisioning. And what's interesting is that many of the conditions that predispose other animals to evolve cooperative breeding pertained among our ancestors. Obviously, very social groups, benefits to group membership, benefits to philopatry, benefits to sticking around and being exposed to those enticing cues from babies that are dependent for a long time. Animals with combined foraging techniques, hunting and extractive foraging, bringing food back to a central place where it can be shared, which probably our ancestors have been doing since perhaps 1.8 million years ago, Homo erectus, and also temporal variability in rainfall and eco-instability. This is just a chart from Rick Potts's work at Lake Orlogasali in the Rift Valley, where one of the sites our hominin ancestors used, showing that the period between 1 million and 600,000 years ago, tremendous variation in rainfall as that lake goes from shallow to deep to shallow. Recently, ornithologists have shown that seasonal variability in rainfall is especially associated with the evolution of cooperative breeding in birds. Just a quick mention of these marmosets and tamarins. Like humans, these guys, they're very excellent colonizers. And one of the things about cooperative breeding is that when times are good, they can speed up breeding, but when times are bad, they can manage to hang on. And one of the things I would suspect is that the name of the game among our ancestors, with very high rates of child mortality, very hard time really making it in Pleistocene Africa, was that the name of the game was not so much mating success as success keeping at least some offspring alive, assuring the proper component in your group of effective hunters and motivated gatherers. These marmosets also have unusually developed other regarding impulses. This is true among wild marmosets, where other group members, not necessarily related to the infants, but sometimes related to the infants, provide about 90% of the food in some species for just weaned infants, and in the lab as well. Christoph cited that study of chimpanzees in captivity showing very little other regarding impulses. Under similar experimental conditions, captive marmosets show unusually other regarding impulses. Great deal of concern for the well-being of others. I don't have time to talk more about them today. What I want to turn to now, though, is what can we say about the psychological implications of cooperative breeding for little apes reared in what for an ape would have been a completely novel social context? Well, we don't have a time machine to go back and see, but we can study their still extant human descendants, among whom psychologists document that babies off their mothers spend more time looking at faces, monitoring eye gaze, and so forth than when they are in physical contact with her. And even without taking evolutionary considerations into account, we know from psychological studies of infants in Western societies that the presence of a maternal grandmother is correlated with increased mother's sensitivity to her baby, more secure mother-infant attachment, enhanced cognitive ability by age 4, presence of older siblings correlated with more sophisticated theory of mind, multiple caretakers correlated with enhanced capacity to integrate multiple perspectives. Also, we find in our species an unusual ability, even in very young children, to assess the motives of others. Infants shown a cartoon of a yellow square helping the little red ball get up, and a nasty blue square pushing the little red ball down. Afterwards, the children will reach out preferentially to the helpful symbol, figure out reputation there. So I want you to join me in a thought experiment. Take a highly intelligent bipedal primate with the cognitive and the manipulative potentials, the rudimentary empathy and theory of mind found in all great apes, then rear that ape in a novel developmental context where maternal care is contingent and the infant depends on care and provisioning from multiple caretakers. Subject this novel phenotype to novel selection pressures such that infants best at mind reading and best cared for are also going to be the best fed, most likely to survive. What do you get? In high child mortality environments, you get directional selection favoring just the traits: enhanced mutual tolerance, social learning, social communication, perspective taking, that comparisons with other apes require us to explain. So what I'm suggesting is that long before behaviorally modern humans with symbolic thought and language, and before the evolution of big-brained, anatomically modern humans, you have the emergence of emotionally modern humans already questing for intersubjective engagement with others. What you have as a byproduct then are the precursors, the building blocks for some of the later developments that you're going to be hearing more about today. So what I've been talking about is simply the prequel to the main human feature film, but some very important building blocks for the kind of social selection that Randy, for example, is talking about when he's saying, how do we explain the peculiarly other regarding impulses that we find in humans that possibly emerged from social selection? You need these building blocks first. Thanks.